Assalamualaikum warahmatullahi wabarakatuh. Dr. Razi. In this video, I will explain about chapter 1, and the subtopic is about the chain rule for multivariable function. Okay, the equation given is given function of f x y z equal to sin x squared times y plus z, where x equal to SR, y equal to r cube plus 3s, and z equal to r squared. Okay, by the chain rule, the equation, once we find the differentiate f function of x with respect to ds and function of f respect with dr. Okay, first of all, what we are going to do is from function x y z equal to sin x cube plus times y plus z, we obtain the differentiate of function or with respect to r, respect to x, and we got 2xy cos in bracket x cube plus times y plus z, and differentiate of function over differentiate y with respect to y, and we got x square cos in bracket x square times y plus z, and differentiate of df over dx, df over dz, and we got cos in bracket x square times y plus z. Okay, from the given in the equation, x equal to SR, y equal to r cube plus 3s, and z equal to r squared, we going to find the dx over ds, and the result is we got r dy over ds is 3, dz over ds is 0 because no variable s in the equation given, and dx over dr is s, dy over dr is 3 r squared, dz over dr is equal to 2r, and we are going to use the chain rule is df. To find the df respect with ds, we must do the multiply or function of x with respect to x and function of x with respect to x, and we will get the df over ds for the x y z function, and from that we got the df over dx times dx over ds plus df over dy times dy over ds, and from that we got the answer from the equation, from the solution we do at the above, and after that we will get the df over ds. The second step is df over dr. We must do some equation like df over dx. We must multiply all the differentiation. For example is df over dx times dx over dr plus df over dy times dy over dr plus df over dz times dz over dr. And finally we will got the answer for df over ds and df over dr.
Hello, today I will discuss about the chapter 2, which is a multiple integral. So this is one of the question that I choose for this chapter. This question is about sketch the region and also how to calculate the area of the curve. This question is sketch the region R in the xy plane bounded by the curve y squared equals to 2x and y equals to x and finds its area. From the question, it asks us to solve this, how to sketch the region R, explained by the two functions and finds its area. So first of all, we have to sketch the region R, and then after that we can find the area. Because to find the area, we must sketch, because we want to find the integral of x and y, multiple integral. This is the graph that I have made for the for the two functions. So this is a y squared equals to 2x, and this is the line graph, the straight line, which is a y equals to x. This is a combination of the two functions in one graph. So it asks us to sketch the region R. There's a region R in the xy plane bounded by the curve for y squared equals 2x and y equals to x. So first of all, we have to find where is the region R, in the to put in the graph. So we just have to find y squared equals 2x in here, and also y equals to x in here. So the intersection between here, there will be area of E or area of B. The either of it, which one we want to choose for the region R. So you say that the xy plane bounded, so we have to find the area that is actually have been closed, that is not the open one. So we will choose the area of E to be the area of R, region of R. So then after that, we can find this area. And now to find the area of the graph, you can say that this is a formula of area. Area will be, the formula will be double integral of here and 1 dA. This is the formula of area of the two functions. So for us, dA is actually can be either dx, dx or dy dx. It actually depends for how we can draw. So here will be vertical position, vertical stripe, and here will be horizontal stripe. So we can choose either of the two, because it will give you the same answer also. So I will choose the horizontal stripes. This will be the horizontal stripe that I'll choose. We can put whatever point or whenever point, because it will be create of the same answer. I will choose the horizontal stripe, right? So to find the horizontal stripe, it will be the area will be this formula. Since the x is in here, so this will be our in x interval. Okay, and here will be y interval. Okay, the interval x will be the functions, okay, of the graph. Okay, so here it is. Okay, we have to find the enter to stripe and the left of stripes. So the enter stripes actually this of this function, right? Of this function, so it will be y squared equals to 2x. Okay, so okay, the enter with stripes will be this formula, y squared equals to 2x, and that left, okay, the stripe is this function, right? So y equals to x. So this will be leave the stripe, and this will be enter the stripe. So it here will be, this is for the interval of x, right? Like I said, the interval of x must be the function. So here will be enter the stripes and leave the stripe. So the formula will be like this. Okay, since we are in the dx, so we have to change that x to be the subjective. So y equals to x will be x equals to y, and here will be x equals to y squared over 2. So this is the formula that we can get. Okay, how about for the interval y? So the interval y, we can solve it, okay, by look for the position of the area. The position of the area will be from 0, right, until this point, but we don't know what is the axis. So how to find the point, okay, of the intersection for both? Okay, to find this point of the intersection, okay, this will be this the way for the step. Okay, first of all, y equals to x must be the first equation, while for the second equation will be y squared equals to 2x. Okay, we have to simulate the x, so the x will be like this. So this will be the new equation. So equation 1 is similar with equation 2. So since the x is similar, so we can say that y equals to half y squared, right? So it will be like this, right? So y is equals to 2. So since y equals to 2, so this the axis, the scales, okay, the point will be at 2. So therefore we can know that, okay, this is the interval of y, okay, from 0 until 2. So it will be like this. So then we can start. Our calculation. Okay, I write back. Simply we write back. 2 y squared over 2 and y 1 dx and dy. So first of all, we have to solve this first, okay, the inner one. So it will be like here, x, okay, because we are doing integration, so every of the power will be always plus this 1 over with the new power in it. So it will be like this. Okay, then we have to integrate of this like the usual, we are using the integration. This is a power of 1, right? So it will be power 2 over 2 minus y cube over with 3 times with 2. So, and then just input the 2 and 0 in it, so we write this. So this is the answer, 2 over 3. It will become like 2 over 3 meter, or maybe 2 over 3 centimeter squared. Okay, whatever it is must be have the power, since it is the area of the functions or the graph. So just that for my presentation. So thank you.
This is example for chapter 3. Find the unit tangent vector, principal unit normal vector, and binomial vector for the given vector valued function. Rt equal to Ti plus 3 sin Tj plus 3 cos Tk. For unit tangent vector, we use this formula. First, we need to find the tangent vector and the length of tangent vector. Then, substitute that two value into this formula and we will get the unit tangent vector like this. First, we need to derive the unit tangent vector to get this. After we get this, find its magnitude. For principal unit normal vector, we use this formula. After that, substitute these two values into this formula and we will get the principal unit normal vector like this. To find binomial vector, we do the cross product between unit tangent vector and principal unit normal vector.
Hello, today I want to explain about divergence theorem. Okay, this is the example of the question, which is it said that the solid bounded by the plane, this is the equation, in the first octane and oriented outward by fxi plus 3yj plus 4k. Okay, for the first step, we need to sketch for the plane. We have three planes, which is xy, yx, and xy, yz, and xz. First, for the xy axis, we know that z will equal to 0. And first, if z equals to 0, this is 0. So we get y equals to 1 minus 2x. And first, we let x equal to 0 and we get y equals to 1. And same goes to y, we let y equals to 0 and we will get x equals to 0.5. So this is for the plane xy axis. And for the second, for the plane xz axis, we know that y equals to 0. So same as the previous one, if y equals to 0, we get that z equals to 1 minus 2x and let x equal to 0. We will get z equals to 1 and let z equal to 0. Then we'll get x equal to 0.5. And this is for the plane xz axis. And for the last plane is for YZ axis, which is we know that X will equals to 0. So let Z equals to 0, we get that Y equals to 1, and let Y equals to 0, and we get that Z equals to 1, and so we plot Y1 and Z1, so this is the plane. And after that we will get we have to determine our plane according to what we have done before, which is X 0.5, Y 1 and Z 1. So this is our plane. Okay, for the third step, we need solve for f and ds, double integral f and ds. We know that first, from this, we know that this is our first plane and this will be our second plane, this will be our third plane, and the fourth plane will be the bigger one, fourth plane. Okay, for the first plane, we know that it pointed towards negative j, so n will be negative j and y will be 0 since there is no value of y. So we will integrate, double integrate for f and ds. We know that f equals to xi plus 3yj plus 4k dot product will with negative j dA. So we will get negative 3yj dA, and since we know that y equals to 0, so the answer is 0. For the second plane, we know that it pointed towards negative I, and we also know that there is no value of x, so x will be 0. So to double integrate f and ds, we know that n is negative 1 dA, and we get negative x I dA. So we also know that x equals to 0, so this also will equals to 0. Okay, for the third plane, we know that it will pointed downwards and it will give negative k. So we know that n equals to negative k and z equals to 0. To double integrate f and ds, so n is equals to negative k and we get negative 4 dA. But for this plane, we need to construct xy plane to get the area. So we know that this is 1 and this is also 1. We know that this is not 1, this is 0.5. And it will enter at y equals to 0 and leave at y equals to 1 minus 2x, because in xy plane z will equals to 0. So after this, we go to this. We know that dA equals to dx dy, and first for the limit x equals to 0 and x equal to 0.5, we put x at the outer space because the x is behind. Okay, so for the limit y, we know that y equals to 0 and y equals to 1 minus 2x. And we integrate, we get negative 4y dx. So at the final answer, we get for the third plane, we get the answer is negative 1. And for the last plane is the bigger plane. So we know that for the last plane, fourth plane, z equals to 1 minus 2x minus 1, and we move z to this side and we will equals it to 0. So it becomes 2x plus y plus z plus 1 equals to 0. And after that, we find for the gradient f x y z, which is df dx plus df dx, df dy plus df dz. And we know that our f is 2x plus y plus z plus 1. So we know that after differentiate 2x plus y plus z plus 1, we got 2i plus 1.
Okay, from the previous diagram, after we find the gradient, so we substitute into this formula to get the value of n. So for double integral, we know that it enter at y equals to 0 and leave at y equals to 1 minus 2x. And the limit for x, we know that it is from 0 to 0.5. So as usual, we substitute the value into this after integrate, and we get the value is 4/3.
Okay, this is for the last step, which is solve for LHS and RHS. We know that divergence theorem states that double integral fn ds will equals to triple integral gradient f ds. First, for LHS, we know that after we made double integral fn ds, we need to sum of double integral plane 1 plus sum of plane 2 plus sum of plane 3 and plus sum of plane 4. And we know that this is equals to 0. We got 0, negative 1 and 4/3. So we got the answer for LHS is 1/3. And for the RHS is for triple integral delta f ds. So we know that delta is equals to d dx I plus d dyj plus d dzk dot product with xi plus 3yj plus 4k dA. And we know that the function of x is the function of f is xi plus 3yj plus 4k, and we got df equals to x plus 3y plus 4. So after this is dot product, we got 1 plus 3 plus 0 dv, and so we bring 4 to the outward, and dv is equals to dz dy dx. And for the limit x, we got 0 to 0.5, and y we got 0 to 1 minus 2x, and for the limit z, we got 0 to 1 minus 2x minus y, and dz dy dx. 1 dz dy dx. So first, we integrate for dz, and we got z, which is the limit is 0 to 1 minus 2x minus y. And after that, we substitute this value into z, and after substitute the value, we will integrate for dy, which is we got y minus 2xy minus y.
After we calculate the value of f and ds and delta f ds, we got both of these give the same value, which is 1/3. So this verified divergence theorem. That's all from me. Thank you.